This is the SOLIS node. In the world of environmental sensing, there is a difference between an estimate and a measurement. Most consumer devices give you the former, a good enough guess. The SOLIS node was designed for the latter. It is a dedicated, high-precision instrument stripped of everything unnecessary, leaving only what the measurement demands. It sits in that same familiar architectural form, a compact piece of equipment shaped to live quietly in your space. It doesn't scream for attention, it simply holds the standard. And the reason it performs so well isn't just because of the precision sensor inside, it's because of how the whole thing is built. Even though it looks like a compact professional measurement instrument, the construction is completely different from normal electronics. There's no traditional green circuit board in here at all. And for something engineered this precisely, making one is far simpler than you'd expect. All you need is a basic 3D printer, or access to one, to build this at home from a few simple parts. This isn't something you buy, it's something you build. We often overlook how much a few percentage points of humidity or a single degree of heat can change the way we feel or how our home breathes. But precision matters. Most temperature and humidity sensors are cheap, inconsistent, and fragile. They drift, they saturate, they lie when the air gets heavy. The SHT41 doesn't. It's factory-calibrated, stable, and designed for industrial and professional environments, the kind used in HVAC systems, medical devices, and environmental chambers. This isn't hobby-grade sensing, this is instrumentation. That's why the SOLIS node exists, to bring that level of reliability into your own space. Most consumer monitors are designed for a season, not a decade. They give you an estimate, not a measurement. SOLIS node is my answer to that disposable culture. A small, quiet instrument built to be trusted, not tolerated. At the heart of the SOLIS node is the SHT41, a professional-grade transducer with factory calibration and a level of stability that is remarkably consistent. It features an internal self-cleaning heater to prevent condensation and drift, ensuring that the data you see today is just as accurate years from now. It is paired with the ESP32 C3 Super Mini, which handles the heavy lifting, sampling, filtering, and pushing that data to the display with a clarity that turns numbers into insight. This is the core of the instrument, quiet, precise, and uncompromising. To house a sensor of this caliber, the internals had to be just as refined. Open the SOLIS node, and you see a completely different kind of circuit. A 3D printed PCB where the routing is defined by geometry instead of copper traces, and the structure becomes the wiring. The wires follow precise paths, locked into place by the chassis itself. The microcontroller and the SHT41 module sit in dedicated mechanical sockets. No solder, no chemicals, no traditional manufacturing waste. It is a clean, physical logic that makes the device entirely modular. Print the body, push the wires into the channels, press the microcontroller into its socket. Mount the SHT41, seat the OLED, close the enclosure, a handful of parts, a few wires, and suddenly you have a finished instrument that looks like it came from a lab, not a hobby bench. If you want a deeper look at how these printed PCBs are wired, I've made a separate video that walks through the technique step by step. It's linked in the description. Precision is useless if the data is trapped. Like many of the instruments in this ecosystem, the SOLIS node is designed to speak through MQTT. It utilizes this specialized, lightweight language, the gold standard for IoT, to broadcast its readings across your network like a private radio station. I've built a real-time MQTT viewer on my site, a space where any topic you publish becomes a living graph. By entering your node's topic, you can see the high-fidelity data from the SHT41 visualized instantly. This isn't a locked-down consumer gadget. There are no accounts to create, no external servers, and no silent data harvesting. You own the hardware, you own the sensor, and you own the signal. It is an instrument that respects your infrastructure and your privacy. Most technology today is a black box, closed, locked, and eventually forgotten. The SOLIS node is the antidote. It is an open instrument. It is accurate. It is repairable. It is yours. It represents a shift toward tools we understand, tools we can rebuild if they break, and modify as we grow. It belongs to a repairable culture, a shift toward tools that stay with you, evolving as you grow. And if you want to see where this philosophy came from, How this approach to open, printable instruments took shape, I've made a separate video that walks through the full story. You'll find it in the description. If you have a 3D printer, the SOLIS node is ready for you. You can download the files, the wiring map, and the firmware directly from my site. Assemble it, flash the code, power it on, take the pulse of your room with professional-grade accuracy. This node is part of the Vanguard tier, a growing family of applied instruments. If you want to explore the other nodes in this tier, the links are in the description. If you want to follow the evolution of this system, consider subscribing. And if you know a fellow maker who would appreciate this design, feel free to pass it along. Thanks for watching. I hope this inspires you to build tools you can understand, repair, and truly own.